Hi everyone, welcome to my YouTube channel Tech Data Engineer. So today we will see performance optimizations in PySpark. So this is very important topic related to your performance optimization in PySpark, because sometimes what happened when we are running our job in productions with the heavy data or real time data. So we come across a scenario where our job takes much time to execute. So that time the latency will be more to face the data after doing multiple computations. So you have to debug your code. You have to see that where we are lagging and what are the optimizations we can do in our code so that our execution time get reduced. Okay, so for that only we have to perform certain steps to make sure that we are not lagging anywhere in our coding part. Apart from that, yeah, we can understand that data volume is one scenario. UDF is one scenario where we have to compromise with time. Okay, so sometimes the data volume is too huge and show that it will take time to do computations, and sometimes you are using UDF. So for that also we have other options, but UDF in most of the cases it takes most time if you are using multiple UDF in your program. Okay, so basically first we will see what is performance optimizations. Okay, so optimization is something where you can reduce the execution time and manage your resource efficiently. Okay, so performance optimizations in PySpark involve tuning and configuring various aspects of your Spark applications to improve the efficiency and reduction time. So optimization is something where based on your configuration resource, how you are utilizing all the resources, how we are reducing your execution time, how we are managing your resource more efficiently. So sometimes what happen, you if you are running your job in a Spark, and if you'll see your history server, you'll get to know that there are certain scenario where if you are executing, if you are in your configuration, if you are adding 5 executor, so sometimes one executor is getting idle, two executor is getting idle because of overload, and some executor are getting overloaded, and because of that it's got failed, and again it's restarted your you can computations. Okay, so these types of scenario happen when you will not balanced your resource or balanced your data. Okay, so we will see certain parameters. Based on that parameter we can optimize our work. Okay, so first thing is tuning the Spark configurations. Okay, so tuning a Spark configuration, under that we have memory management. So memory management is something where you have to define your executor memory. So suppose your executor, if you are in your Spark submit command, you are defining you have two executor, then what is the executor for memory? So allocation of adequate memory for Spark executor. So either too little memory, like if you are using, suppose you are running your job and if you are using your memory is too little, then what it will do, every time it will do the frequent garbage collection and out of memory issue. So so based on your data, based on your job, okay, you have to come across a certain number where you can give that like 2 GB of executor memory or 4 GB based on your data value. If you'll give more, so it will come as a insufficient resource usage. If you'll give less, every time it will do the garbage collections or out of memory issue, so that you have to take care. So under memory management you have to take care two things: one is the executor memory, one is the driver memory. So driver memory, if so you have to allocate the sufficient memory for a Spark driver, especially when your application have heavy job scheduling or large amount of data. If you are running that, then you have to take care of this Spark driver memory things also. Okay, then core allocations. So like what are the number of executor you are like per executor you are doing per core. Okay, number of cores per executor, sorry for that. So in one executor how many cores you are assigning, 2 core, 4 core, something like that. So increasing the number of cores can improve parallelism. So if your core is more, your job will run more parallelly. Okay, but you have to balance the memory allocation and task overhead also for that. Then spark task cpu, so you have to specify the number of cpu core required for each task. So in core allocation you can take care of your number of core per shooter or number of cpus. Okay, number of CPU core required for your task. Then now come to shuffle partitioning. So you have to define your num partitions also in your job. So how many partitions you wanted. So configuring the number of partitions to use for shuffling data. A high number of partition also, if you are using high number of partition, then can reduce the size of each partition but increase the overhead of shuffling. So you have to give a balanced number, either not too low or not too high. If you give too high partitions, so it will reduce the size of each partitions but increase the overhead. Okay, so I have to take care of that things also. So under tuning spark configuration, first comes as a memory management. Under memory management we have to take care of executor memory, driver memory. In core allocation we have to take care of executor core, task cpu. In shuffle partitions we have to give the number of partitions for balancing the data. Then now comes to data storage and cache. So what we are doing, sometimes in our job we are storing the data in data frame df, but we are not persisting the data or not catching the data, and that particular cache and persist that particular data frame is getting used multiple times in your later computations. So what happens, if required to compute again, it will start computing from beginning. So what you have to do, you have to cache or persist the data based on your requirement. If you are in memory sufficient, you can do in cache, or you can give the storage label as a persist also. So you have to define your cache, then storage label, either memory only, disk only. So based on these techniques you have to do that, so it will help to do the faster computations. If your computed data frame is required, if your computed data frame is uh, required to compute recompute again, then it will take that the result and it will not start from the beginning. So cache and persist also play a very important role in your optimizing your job. Okay, then efficient data processing. So you have to, if you are joining multiple data frame and one data frame is small enough and one is big enough, so try to use broadcast join. So broadcast join, basically it will, but it will, you don't, your bigger data frame do not have to shuffle, because shuffling is a very, you can say, expensive operation. So you can broadcast your small data frame, and you can do that. So using broadcast join when joining larger data frame with a smaller one. So broadcasting the smaller data frame avoid the cost of shuffling. So shuffling is a more costing operation, so you can broadcast your small data frame. Okay, then repartitions. So use repartitions or collages. So repartitions or collage basically used to increase or decrease the number of partitions. Okay, repartitions is more expensive, but can help balance data, while collage is used to reduce the number of partitions. So you can use either broadcast join, repartitioning, so that you can avoid the shuffling. Then minimize the number of shuffle operations like group by. So in your code, if you are using group by, reduce by key, or join, so try to minimize as much as possible, because it will unnecessary overhead your data movement across the network. Okay, which is expensive also. So in efficient data processing, you try to use your broadcast join. If your scenario is like that, if your one data frame is bigger, one is smaller, then use the repartitions. Okay, for data, if you're in balanced data, then use repartitions collage for number of partitioning. Then try to avoid shuffling, like group by, reduce by, join, if there are more things are there. Then fourth is query optimization. Okay, so you can use catalyst optimizer, which will leverage spark sql and catalyst open for query optimization. So ensure, if you are using any sql queries, so that can take the advantage of a spark built-in optimizations. Okay, so based on this you can optimized your query. Then data skewness, so sometimes there is a skewness in your data, so you can use the sorting or random distribution. So if we have data skew data in your job, then definitely it will take much time. Okay, so you have to handle the data skewness by using techniques like sorting or bucketing or adding a random prefix to the key. So distribute the data evenly, okay, across partitions. So each partitions you can evenly distribute your data. Okay, then there are some advanced topics which is based on that you can optimize your job, like dynamic allocations. So enable dynamic allocations, which basically allocate the data dynamically. Okay, that automatically adjust the number of executor based on your workload. So if your data volume is more, based on that your workload, if your job have multiple UDF, so it will do some fractioning of the memory, and it will allocate the it will allocate your memory. So it will, this is one of the optimized technique to allocate the resources. Then Kubernetes integration, deploy Spark on Kubernetes and use Kubernetes feature for managing the resource. So use Kubernetes integration to that. Then third one is the most important, adaptive query execution. So you can enable your AQE to optimize query plan dynamically based on runtime statics. Okay, so this basically improve the performance of complex query. So if your complex query, if you have enabled AQE, this will basically optimize your job. Okay, then next is the monitor and debugging. So you can monitor, if whenever you are submitting your job, you can monitor your logs from Spark UI, or try it, Spark UI basically, which will tells that where is the task, what is the resource utilizations, you are using df dot show multiple times or count or actions multiple times. So you try to avoid that things. Then you can check the logs and matrix. So analyze Sparks logs and matrix. You can see the lineage graph, DAG, this one you can see. And then you can check the history server of the Spark applications, where you can debug the things, what are the steps, which stage takes more time, and where is the chance of improvement. So you can just see the logs and matrix, and then you can improve your job. Then next is the data format and compressions. So sometimes what happen, because of data format also your task takes much time. So use column format like parquet file, orc, instead of row based format like csv and all. So if you have large data set, try to use parquet file or orc file, like column based storage. Then try to use compression. So apply compression like ggp or snappy to reduce the data size on disk and during shuffles. Okay, so which can help in speeding up the data reading and writing. So you can use all these techniques if you can come across your job, if it is taking much time. So if there is a chance of improvement, you can improve that, and you can run your job, and you can recheck again your job is getting improved or not. Then eighth is the one of the important things, UDF optimization. So every time whenever you will see, if you are writing a UDF, Spark UDF, so that will take much time compared to Pandas UDF. So if there is a chance, if there is a possibility, then try to use Panda UDF instead of Spark UDF in your Spark application. Okay, because Panda UDF are more efficient execution, more efficient, and that can be vectorized also. So that's why which is faster than traditional UDF. So try to use Pandas UDF instead of your Spark UDF. Okay, so these are the optimization techniques which basically we can use. So we can see in one more time. Okay, one is the tuning Spark configurations. So in a Spark configuration, you can check the memory management, executor memory, driver memory. In core allocation, you can check the number of core, number of CPU. Then in shuffle partitioning, you can partitions based on your you can use num partitions to shuffle your data. Then under data storage, you can use cache or persist techniques. You can use the different storage label and persist techniques to avoid the recomputations. Then you can use efficient data processing, either broadcast join or repartitions or coolage. You can avoid shuffling also, like reduce by key, group by key. If that is in your job, try to avoid that. Then in query optimization, you can take the help of catalyst optimizer or data skewness. You can handle your data skewness by salting or bucketing. So these are the technique you can use. Then other is the advanced techniques like dynamic allocation. You can enable dynamic allocations. You can integrate your application with the Spark application with the Kubernetes. You can enable your AQE. This is basically you can dynamic memory execution plan. Then you can see from UI Spark UI can monitor and debug Spark UI history server, and logs you can monitor, Kibana logs you can monitor, and then based on that you can just check where the chance of optimizing your work, optimizing your job. Then data format and compression. So try to use column. If your data volume is too high, try to use you can say compressions data like columnar storage instead of row based storage like CSV and all. Okay, try to use some compression technique if there is a chance to compress that. Then UDF, in UDF you can use either you can use instead of traditional UDF like a Spark UDF, you can use Panda UDF. So these are the techniques which we have listed out. You can use in your application, and then you can try to rerun so that you can just check if there is a chance to get your job get optimized or not. Based on this all this parameter, you can configure and you can check so your job get optimized. Okay, thank you, thanks for watching.